I'm going to do 15.2, which is multiplication, division of rational expressions. And I did put how to submit the extra credit if you want to submit the extra credit. So the first thing is so when you multiply rational expressions, just so you remember what a rational expression is. So a rational expression is just a polynomial divided by a polynomial as long as the denominator does not equal 0. So an example would be 3x plus 1 over x minus 5 would be a rational expression. I'm not going to go ahead and read those. I'm just going to go ahead and start doing these. Now, when you're multiplying rational expressions, what you want to do is you want to simplify. You can simplify diagonally and also from numerator to denominator. When you simplify, don't go left to right. So when we see these here, I can get rid of a b. Just make sure you write the number 1 so you know that there's a 1 there that took place. You also can divide. I'm going to simplify the 2. 2 goes into 2 one time, goes into 6 3 times. 5 goes into 5 one time, goes into 10 twice. So when you do these, you notice that on the left hand, my numerator, I have a to the second power, but I have an a. So it's 3a to the third power over 2 will be your answer for example number 1. Example number 2 is the same thing. So I'm going to simplify the b's. Now I'm going to go ahead and simplify the a's there. Now 3 goes into 3 one time and goes into 15 5 times. 7 goes into 7 one time and it goes into 14 twice. So you can see that I have 1 times 5, which is 5 in my numerator, and then I have 1 times 2a, and so the answer is 5 over 2a. In this one here, I want to factor out first before I go ahead and simplify. So I have a 3 times c minus d over 6d and then 2. So remember that a squared minus b squared is a difference of squares. So it's a minus b and then a plus b. So I'm going to write that here. So a minus b, a plus b. Oh, sorry. It's not a minus b, it's the c. Sorry. So it's c minus d and then c plus d. So I can cancel out a c minus d. I got to put the 1 there. 2 goes into 2 one time and it goes into 6 3 times. So when I multiply across, I have 3 times 1, which is 3, and then my denominator, I have a c and a 3. So I can actually cancel out a 3 also, so that goes into 1 time there. And so my numerator is just 1. And then my denominator is going to be c times c plus d. Going to the next one here, again, I want to factor out as much as possible. So I have a 4, and then I have an x minus 2. I have an x plus 6 here. Here I'm going to factor out an x, so I have x plus 6, and then I have a 2x. So what I want to cancel out is the x plus 6 first. I can also cancel out an x. 2 goes into 2 one time and it goes into 4 2 times. So my numerator is 2 times x minus 2 over 1. And that just becomes 2 times x minus 2. The next example, again, I have to factor everything out. So I'm going to go ahead and do it this way. Here I can take out a 5. So it's going to be 7 minus x. Take out a 5 here, so it's going to be x plus 1. And then, of course, my denominator on the right side, it's also a difference of squares, so it's going to be x minus 7, x plus 7. And then for my numerator on the right side, it's going to be x plus 1, x plus 4 if you were to factor those out. So now, one of the things that I want to show you is that if I have 7 minus x, that is equal to negative 1 times 7 times x minus 7. If I distribute the negative, I can go ahead and rewrite this as 7 minus x. And so this becomes 7 minus x. So if we know that this is equal to negative 7x minus 7, if I divide both sides by x minus 7, I get negative 1. Where you put the negative 1, it doesn't matter, but you have to put it somewhere. Cancel out the x plus 1s. The 5s will cancel out. And then I'm left here with x plus 4 over x plus 7. So just remember this right here because you'll see that quite a bit. Oh, negative, sorry, because I have the negative 1. So it doesn't matter where I put the negative. I can put it in the numerator. I can put it in the denominator. It's going to be the same thing no matter where I put it. So just a heads up. This one's extra credit. Email it to me. Complete. Show all of your steps. Now the second part is division of rational expressions. I'm going to go ahead and work this one out. So what I would do is you keep the first fraction, change the operation, and then you go ahead and flip the second fraction. Go ahead and factor as much as you can. Again, that's a difference of squares, so it's going to be t minus 3 and then t plus 3. So I'm going to cancel out a t minus 3. 2 goes into 2 one time, and it goes into 10 5 times. Put the 1 there. So 5 times 5 is 25, and then my denominator is just going to be t plus 3. All right, the next example, again, we're going to keep it the way it is first. And then I'm going to go ahead and change it. So find the reciprocal of the right side. And then I'm going to go ahead and factor. So I can factor out a 7 here, which is y minus 2. Y plus 1. Take out a 2, so I end up with y plus 1. And then this one looks like it's going to be y plus 4 and y minus 2, so you can factor out that way. I can cancel out a y plus 1. I can also cancel out a y minus 2. And that looks like that's all I can do. So 7 times 2 is going to be 14. And then it's going to be 14 over y plus 4. Double check your work to make sure that that's your final answer. And this one here, again, I'm going to keep it the way it looks. First, I'm going to change the operation and find the reciprocal. So it's going to be 2p plus 4 and then 30p minus 5p squared. So now I can go ahead and factor this out. So this look is like it's going to be p minus 5, p minus 6. I'm going to factor out a 10 here. I still have to factor that out a little bit more, but I'm going to do it in a second. So I take out a 2, and then here I can take out a 30p, which is going to be 6 minus, sorry, it's not going to be 6 minus, I took out the 30. So that one's going to be a p minus, oh, let me do that one again. I actually take out a 5. So take out a 5p, so it's going to be 6 minus p. So now I can go ahead and cancel out. So remember, that's going to be a negative 1. And then I'm going to factor out a little bit more here. I'm going to put the negative 1 here. So I'm going to do p minus 5, p plus 5. And then I got the 2 times p plus 2, and then the 5p times 1. I just got rid of those. So p minus 1 I can cancel out. So then I'm left with negative 2p plus 2 over 50p, and then it's going to be p plus 5 because I just multiply everything in the denominator. Now here I can cancel this further, so that's going to be a p plus 2, and then it's going to be a 25p p plus 5. Now that's going to be extra credit for you guys. Now this is a complex fraction, so I'm going to rewrite it so it can look the same way the other ones looked. So that's going to be 3x over 4y divided by 5x over 6y, and then I'm going to keep the first fraction, change the operation, and then I'm going to find the reciprocal. Cancel out the x's, cancel out the y's, and then 2 goes into 4 2 times, and it goes into 6 3 times. So 3 times 3 is 9, 2 times 5 is 10, so 9/10 is the answer for that one. Here's the same thing, so I have a cubed b over 9c, and then I have 4ab over 3c to the third power. So I'm going to keep this one, change the operation, and find the reciprocal. Now once I do that, I'm just going to cancel out. So cancel out the b's. I'll cancel out 1a. Cancel out the c, so that becomes a 2. And then of course the 3 goes into 3 one time, it goes into 9 3 times. So for my numerator, it looks like I have a squared c squared, and then my denominator looks simply like I have a 12. So just double check everything, make sure everything was canceled out correctly. Now for this one, I'm going to keep it the way it is, but I'm going to change it into a multiplication problem. Now I can cancel out straight across. So 4 goes into 4 one time, into 8 twice. 3 goes into 3 one time, into 6 twice. Now you know here that this is going to be a c plus 3 if I do the c minus 3 and then the c plus 3. So when I go across here, it looks like I'm going to have a c in my numerator, and then my denominator looks like it's going to be 4 times c plus 3. And that should be your answer for this example. I'm going to leave this one extra for you guys so you guys can knock that one out. And that is the end of 15.2.